Hi everyone, this is a question by Sujay Kumarji on the live stream. He's asking, how do we rate the accuracy of Teachable Machine versus Runway versus Lobe when it comes to image classification? So depending on where you're training and what type of model and what type of data and how data is being pre-processed, many factors, your model is going to be more accurate or less accurate in different types of data. In this case, all of these different tools, Teachable Machine, Runway, and Lobe, they're providing us with a way to train image classification models without writing a single line of code. They allow us to just prepare a data set somewhere, then drag and drop them or add them with a folder, and then train the model and export it to multiple different formats, specifically Teachable Machine and Lobe. I'm not sure about how Runway at the moment is letting you train a classifier, or whether it's doing it or not. The thing is, we can train this model to many different places, TensorFlow.js, TensorFlow Lite, TensorFlow Core, run it as a local server, but they are all using slightly different strategies. So they might use ResNet that was created by Microsoft, a deep residual network. They might use MobileNet. They might use Inception, different neural networks to classify that are using different strategies to learn features from your images. This means that the models are going to perform differently on the same type of data. But if we start and train models in Teachable Machine and Lobe using exactly the same data, we're also going to see different results because, for instance, Lobe doesn't let us change the amount of epochs or the learning rate or other parameters from a model, whereas Teachable Machine lets us do it. And if we use TensorFlow Core or TensorFlow.js, we're going to be able to customize everything up to the smallest level. This means that those parameters are important and we're going to get different accuracies, and there will be models that might classify some types of images better than others. Line drawings might be recognized better by one type of network, and photographies might get recognized better by other networks. What I would recommend is that you understand really well what the confusion matrix is, what the accuracy metric and loss metrics are, and how to measure them. In Teachable Machine, we can see the loss going down over time, and we can also see the confusion matrix and the accuracy of the model. We can see those parameters changing as we train, and also how they evolve as we change the number of epochs that we have to train for, and the learning rate and the batch size. What you will do if you train these models in the different tools that we're seeing here with the same exact data set, you will save the models to the same format, say TensorFlow for Python or TensorFlow Lite or TensorFlow.js, and then try to run them through the exact same evaluation data set and try to create your own graph of accuracies, confusion matrix, and all these things. That way you will understand which of these models with the exact same data, maybe the same configuration like epochs or learning rates, is better learning to classify your images. This is a common process. With this data, which model is going to learn the fastest, is going to train the fastest, or is going to be the optimal, is going to execute faster, and is going to classify my data better. I would say it's not only about the accuracy. Accuracy is really important, but there are other things like speed of execution and how optimized the model is for you to be able to run it maybe on the cloud or on a device and have fast predictions. Sometimes we trade accuracy for speed. So maybe if you get a 99 or 97% accuracy in 10 seconds, it's better to get a 92% in half a second, because that's going to provide the user with a better experience. The gist of this would be different tools might use different neural networks, and even if they use the same neural network, they might use different strategies to retrain these models and to export them. Let's say one might export the TensorFlow Lite model as is, the other one might allow you to quantize it and have a bit or less accuracy with more performance. So yeah, different tools, different models, different accuracies, different results, but the most important, learn how to measure the accuracy of the models on your own, and then use the same evaluation data set on the various different models that you've trained to measure which one is the best for the use case that you want to use it. You might be looking for good accuracy, but with a really good performance. Other days, you might be interested more in having the highest accuracy possible, and you don't mind about performance because you don't have to execute things on real time. I hope that this answers, and thanks for your questions, Sujay. This was one more video of the machine learning series. Go ahead and like the video if you want to let me know that you enjoy the content or you would like to see similar videos. Subscribe if you want to get notified when I go live in the future or when I upload new videos, and join the Discord community where you can share your projects. We can discuss things that have to do with machine learning, podcasting, sketching, drawing, creative coding, anything really. And we can get to know each other a bit more. Thanks so much for watching, and I'll see you next time.